Welcome to The Explainer. Today, we are going to break down something pretty cool: how a machine actually thinks when it plays a game. And more importantly, how that same strategic logic is starting to change, well, pretty much everything.
You know, it's a question that's fascinated people for decades, right? How does a computer, a bunch of silicon and code, manage to outsmart a human grandmaster? Well, today we're diving straight into the world of game-playing AI to uncover the cold, hard logic that powers a machine's winning moves. All right, so first things first, we gotta understand why games are such a perfect playground for artificial intelligence. I mean, why not something else? What makes a game the ideal training ground? So, here's the key thing to get. Game playing in AI isn't about feeding a computer some secret playbook of winning strategies. Not at all. It's more like teaching it the absolute basics. Here are the rules. Here are the moves you're allowed to make, and here's what it means to win or lose. That's it. The AI's job is to figure out the rest all by itself. And this whole approach works so incredibly well because games are basically the perfect sandbox, right? They're these neat, tidy, structured worlds. The rules are crystal clear. The goal is obvious. This forces the AI to get really, really good at complex problem solving. And maybe the best part, success is totally black and white. You win or you lose. There's no gray area, which makes it the perfect environment for an AI to learn, adapt, and get better. Okay, so we know why games are great for AI. But how does it actually decide what to do? What's its next move? Let's pull back the curtain a bit and look at the core strategy that powers its thinking. Well, the secret, and it's a big one, is all about thinking ahead. It's not magic. It's just about being unbelievably good at looking into the future of the game. And it does this using a super clever algorithm that just maps out all the possibilities. And that algorithm is called Minimax. The name kind of gives the whole game away, doesn't it? It works by trying to maximize its own potential score, while at the very same time it assumes that you, its opponent, will always try to minimize that score. It's this beautifully simple but incredibly powerful form of digital paranoia. So at its heart, it's just this constant battle of logic. Let's say the AI is player one. Its only goal is to maximize its score, so it's the maximizer. It's always looking for the path that leads to the highest possible number. But, and this is the crucial part, it always assumes that its opponent, player two, is the minimizer, and that they will do everything they possibly can to force the lowest possible score. Now, I know this might sound a little abstract, so let's make it super concrete. Let's see this thing in action. Imagine our AI, player one, is about to make a move. The algorithm starts by building this huge game tree that maps out every single possible outcome from this one decision. Okay, now here's where it gets really interesting. The algorithm doesn't start at the beginning, it starts at the end. It jumps all the way to every possible final outcome of the game, we call these the leaves of the tree, and it assigns a score to each one. Simple rule, the higher the number, the better it is for our AI, player one. So, with those end scores in place, the algorithm starts working its way back up the tree. At this level, it's player one's turn to make a hypothetical choice. And since it's the maximizer, it's always going to pick the best option for itself. So if it's looking at a branch that leads to a 10 or a 25, well, it's going to assume the 25. If it sees a 15 or an 8, it picks the 15. It pushes that highest possible value up to the next level. Okay, now we back up one more level. And at this stage, it's player two's turn. Remember, player two is the minimizer. Their only goal is to make things as bad as possible for our AI. So when player two has a choice between a path that leads to a 25 for the AI and another that leads to a 15, it's going to pick the 15 every time. It forces the game toward that lower score. The same logic happens on the other side, and the 23 gets pushed up. And here we are, all the way back at the top. We're at the root of the tree, the actual decision the AI needs to make right now. And it's looking at two main paths. Thanks to this whole process of looking ahead and assuming the worst from its opponent, it knows that one path has a guaranteed value of at least 15, and the other path has a guaranteed value of at least 23. So, what does it do? Well, as the maximizer, the choice is obvious. It picks the path that leads to 23. And just like that, it's figured it out. It's used Minimax logic to choose move C, which is its optimal strategy. It has guaranteed the best possible outcome for itself, no matter what its opponent tries to do. Pretty smart, right? So we've just walked through this beautiful, kind of perfect logic in a really simple game tree. But what's so cool is that the power of this kind of strategic thinking
It doesn't just stop at the edge of a game board.
I mean, this kind of strategic thinking, which was perfected in games, has been a massive driver for the entire field of AI. We're talking robotics, economic modeling, even complex military training simulations. But let's be real, it's not a silver bullet. The problem is scale. For a game like chess or even more so Go, the number of possible moves is just astronomical. We're talking more moves than atoms in the universe. So simple minimax just won't cut it. It becomes incredibly expensive computationally, and that perfect, clean logic of a game board doesn't always translate perfectly to our messy, unpredictable real world.
So, what does all this mean for the future? Where are we headed with gaming and AI?
Well, from mastering strategy games that are just way too complex for any human to handle, to creating dynamic, unpredictable game worlds on the fly, AI is totally reshaping what interactive entertainment even is. Think about it. It's not just about making tougher bad guys to fight. It's about creating entirely new kinds of experiences that can adapt and respond to you, the player, in ways we're really only just beginning to imagine.
When you really think about it, games are just the beginning. They're the perfect training ground, the perfect benchmark for a powerful new way of solving problems. You see, when we teach a machine to master a game like chess, we're not just teaching it chess. We're teaching it a fundamental form of strategic reasoning. And that leaves us with a really big question to chew on. If AI can master our games, what's it going to master next?